Good morning. It is Sunday morning here. It's about 7:35 a.m. So I'm going to try to sneak in a quick lab here before the house stirs and the coffee gets going and my wife makes her Sunday pancakes. So anyway, we're going to do just something that a viewer posed yesterday. Demetrios was asking, hey, what if when you do a GRE tunnel, is it possible to build a functioning GRE tunnel when the IP addresses of the tunnel are discontiguous, in other words, not in the same network? Typically, you configure these as if, they are, for example, directly connected interfaces. You might do a slash, um, 30 or slash 29, something like that. But it's an interesting question. I did not know the answer. My gut says that you probably cannot. I have not researched this, but I want to just lab it up and see. By the way, this movie, we saw it last night, the Blade Runner 2049. I've had very few theatrical or experiences at the movie theater like this. And I say that with all sincerity. My wife is not a big sci-fi fan, saw it with me. Absolutely loved it. Was a gasp. I mean, highly recommend this movie if you get a chance to see it. So, loved it, loved it, loved it. I know that's not what this channel is about, but it is a vlogging channel. It's something we did yesterday. It did take me away from studying, but it was a good break. Well worth it. And that rarely happens in the theater anymore. So anyway, what we're going to do, we're going to try this little challenge. Demetrios posed it yesterday. He said, can we do this? So I'm going to try it with the same topology here. And this is going to be, we're going to build a GRE tunnel between router 7 and router 8 in this topology. And as you can see, of course, an advantage of this with BGP was that we can do an eBGP peering as if this is a directly connected network. So in that directly connected neighbor. And in that case, you don't have to do eBGP multi-hop. It passes the directly connected check. So that's cool. But let's try this. I already have the simulation running. So what we're going to do on this is the INE BGP over GRE topology. So we're going to shut these switches down and we're going to give this a shot here. Stop nodes. I didn't mean to do that. Simulations. So yeah, we're going to do that. We're going to launch terminal. And then we're going to open up all these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, we already built this yesterday, but I ran out of time to try this out. That's why I want to do that today. Before I get into some other labs, I'm going to be labbing hopefully throughout the day. I've got a couple errands to run, but just to let you know, I'll probably just do this quick lab before breakfast this morning. But we're going to configure this on router 7 and router 8. I think with this topology, everything else is pre-configured as far as BGP goes. We got AS54 here, AS200 here, and router 7 is in AS100. So this is eBGP. But the important thing is, let's open up a terminal here, or text edit. As a matter of fact, I still have the configuration files from yesterday. These are future desktop Skypes. They're going to be in wallpapers of the day. We're going to be looking at Blade Runner a while. This is pretty awesome. Yeah, so we did the configs was this. Yeah, I already got these. So we got router 7 and router 8. That's where all the configurations were. And what we did is we did tunnel mode, GRE IP, tunnel source, tunnel destination. So we created this new, this is the IP address of the tunnel router 7, 151.77.1. And what I want to do over here on router 8 is the same, IP address 151, but we're going to do 78.1. So these are in completely discontiguous networks from each other. The question is, will they be able to form I think the tunnel will come up, to be honest, because the tunnel is going to rely exclusively on, the mode, the source, and the destination to negotiate. And there's not a lot of requirements for these tunnels to form, right? But that doesn't mean you're going to be able to communicate over the tunnel. And I think that's what's going to happen when we do this. We got an error yesterday, though, so I want to see that error again. Let's go 1, 2, 3, 4, 5, 6, 7. This is router 7. Most cases. Yeah, it's already loaded up. So we're going to put this configuration in there. The BGP part, I'm not too concerned about. Notice, see, we already know this, right? With the GRE tunnel, there is no checking, unlike a physical interface. Physical interface, there are at least layer 1 checks for the interface to come up, but this is a virtual interface, just like a loopback. So it's going to come up. Doesn't mean the tunnel interface is up here. Doesn't mean we can communicate over the tunnel interface. So let's do the same over here, router 8. He has a little more configuration, but that's fine. Yeah, in this case, router 8 is also going to do eBGP peering with router 10. This AS200, that's AS54. That's what and it used authentication. That was part of the lab yesterday. So, but let's see what happens. So the neighbor's up. I do not expect the tunnel interface is up, but what's going to happen? Well, with this virtual interface, I think what's going to happen is we're not going to have reachability, because this is 77.1, this is 78.1. So just as if we had two physical interfaces linked and they were on different discontiguous networks, they would not be able to reach each other. So let's see. 151.77.1. No, and we can even source it, I think. And it's not going to work. So we're not going to form a BGP peering over this tunnel link. Now the question came up, well, what if these interfaces, can this network segment be routed in EIGRP, in your IGP? Or could you do, for example, a static route? Let's try first with a static route. Well, no, let's try first with EIGRP just for fun. So let's put this in the EIGRP. See, the problem is, I think, is that if you add this interface to EIGRP, I guess it will advertise it to its neighbors. Let's see. Router EIGRP 100. I think EIGRP is running here. Show IP route EIGRP. Yeah, it is. And this is, we have, for example, router 8. Yeah, we're learning from router 8. So what if we do network 151.77.0? So we're going to put the tunnel interface into EIGRP like we would a loopback interface. Let's do the same here on router 8. What did I say it was? 78? Yeah, 78.1. With /24, just make it interesting. All right, so we've added that in EIGRP. Do we have... Yeah, okay. I thought that's what we would get. So your EIGRP is saying, nope, you can't do that. Well, it's saying the neighbors, so naturally it's trying to form a neighbor adjacency with this interface because we've enabled EIGRP on this interface. We can, of course, turn that off, right? There's a way to turn that off, I believe. We can do passive. let's see, router EIGRP 100 interface, passive interface. Let's try that just to get rid of the errors. And again, this is kind of like hacking to me. I mean, this is way beyond what the intention of a tunnel interface is. This is not how they're supposed to work, right? But we're just doing an experiment. We're just having some fun. We're going to say passive interface T0. Now, will that still advertise the route to the interface? I don't think it will, to be honest. Let's see. Show IP route EIGRP. Well, no. Yeah. Well, we've got 77. Yeah. So we are learning it. Interesting. So can I ping it now? And look at this. It is going out the physical interface. Well, I'll be. Okay. Hey, look at that. So now that we have reachability, and theoretically it would take the same path if it was encapsulated already, right? It would go this way, physical interface, right? So that is the physical interface that traffic for that destination would take normally. Interesting. So now let's try to do BGP across that. Let's say, what was the command here? I think it's already configured, but there must be some sort of check. Yeah, that's probably going to fail, isn't it? Now, what if we did multi-hop? Neighbor. I mean, there's so many reasons why this should not work. The fact that we're trying to make it work is, again, it's just for fun. Let's do that down here. It makes more sense here. Let's put it in there. Let's just see. Yeah, this should not work. Let's debug IP BGP. Connection refused by remote host. And when you think about it, yeah, because, so what is going to be the source? Oh, we'd have to change the source, wouldn't we? Yeah, the TCP connection will not form because the source address is going to be different from from the neighbor address it's configured. So what if we do this now? This is the last thing I think we can even attempt to do, is if we say neighbor source, what is it, source? Forget the terminology here. Router, BGP 100, neighbor. Update source, right? Update source T0. This should not work, guys. This should really not work at all. Uh-oh. So we're probably not getting correct ACKs yet. Router, BGP, 200, neighbor. And let's do a clear IPBGP. Interesting. It came up. Huh. It actually formed a neighbor adjacency. Show IPBGP neighbor. Show IPBGP sum. Huh. Wow, what do you know? We made it work, but not in a good way. uh, yeah, I'm not sure why you would ever do this. When you have the option with a tunnel interface to use whatever, whatever IP address scheme that you want, typically you would do it just like a physical interface. Why you would ever configure something this way, I don't know, and I'm actually shocked that it sort of passes all the checks, but it works. So again, I'll just show you guys. Show IP interface brief. Here's our tunnel, 78.1. And here's 77.1. This /24 doesn't really show you there. Encapsulation tunnel mode GRE IP, and yet here we have show IPBGP neighbor. Just do a summary. It's up, the tunnel is up, and we have 11 prefixes received. And sure enough, let's try to route. So let's see, show IPBGP. So we have learned the loopback. Let's do a trace route. Let's see what this trace route looks like. I don't know if he has show IPBGP. Okay, he has a route. Oh, we've got some problems, don't we? Yeah, we got a new sub. For some reason, my Streambox is disabled right now. I've had some issues in OBS, so sorry about that. Normally, you would see that on the screen. But thank you for the sub, whoever that was. I need to fix that. I'm going to work on the stream today. Okay, here's the thing. Show IP route EIGRP. Oh no, show IP route. Okay, so here's where we have a problem, right? Because I don't believe that we're advertising this into EIGRP or not. Yeah, so we're not learning this via EIGRP, so we're relying on BGP and show IP route. distance 20, right? BGP 200. And we have reachability here, right? But and we should have reachability the other way. In fact, let's trace route that. So this is interesting. The tunnel is up, but the traffic is not trying to go over the tunnel. Yeah, I'd have to capture this to see what is really going on. Let's do that. The tunnel adjacency is formed, but the routing does not work this way. And let me see if I can, yeah, I do want to capture anyway. I do want to capture this on router 8, for example. J01. And this is, yeah, see what's happening is it's not really using the tunnel. That's the problem. Normally you would see this in a standard tunnel as, I believe, when you do a trace route. I could be wrong. But either way, the routing is not working. So we're learning this through router 8. It's going 200. That's AS200. So if I try to reach that, it's unreachable. Yeah, none of these routes are reachable. So we were able to get the adjacencies up, the BGP neighbor adjacencies, or the TCP connection. The handshake succeeded, but the routing is all messed up. So, well, that was a fun little experiment. Now, just to prove a point here, let's put these back to what would be a standard tunnel address. So let's say this is 77.2, right? And let's say neighbor is 77.2. Making those contiguous. In this case, we don't need multi-hop. This is going to work after that, right? So now if we do show IPBGP, give it a second, neighbors up. Learning routes. And at some point we should learn the loop back. It's still converging. But we should learn the loopback here from router 7. There we go. And as we can see now, everything is working the way it should. So I'm a little surprised that it actually allowed the TCP handshake to work. But once we established that layer, that actually worked over the physical interfaces, right? Establishing the TCP handshake with the eBGP multi-hop. We made it work, but to our own detriment, because I believe I have to source these from loopback 0. Yeah, see, that works now. Yeah, before we did we source it correctly before? Hmm, maybe that was a problem. Let's put it back and just see. Update source. Interesting. Maybe that was the issue. I had forgotten all about that. Now, if this works, I'm really mind blown here. Not mind blown necessarily. Okay, let's see what happens. Neighbors up. Both neighbors are up. We expected that. That happened before. Now let's wait for the tables to converge here. Ping 150.1.8.8 source L0. Repeat. So we should see this come up. We had reachability to loopbacks before. Okay, best path still not established. There we go. So now, show IPBGP. Nope, doesn't work. Wait a second. What, did it just need a little more time to converge? It did. Wow, it works. We made it work. Huh. Fascinating. So in this case, it is actually working. This is 77.1. Tunnel interface is 78.1. The routes from eBGP neighbor router 10 are being learned on router 8, and then they are being advertised to router 7. And then 7 is able to reach all those. Wow, fascinating. Let's see. Let's go to router 7 again and just do a trace route. Wow. It even looks like it even trace routes over the tunnel. Trace route 8.119.16.1 source L0. That was what I didn't do before. Look at that. Even trace route doesn't realize, I mean, it's doing what it's supposed to do, but wow, we got it to work. So this configuration does work. Again, interface tunnel 0, IP address 155.177.1. Neighbor, we had to do these changes to get the neighbor adjacency to work. But the neighbor's on a different subnet, 155.1.77.2. And again, we're using update source tunnel 0, eBGP multi-hop. And it works. Who would have thought? It doesn't break all the different checks. It actually works like a regular tunnel. So, which is of course a virtual interface. Well, great. I hear the wife, making breakfast. So I'm gonna break here, guys. We hacked this thing. We got it to work. Interesting stuff. It's always good to know because you never know what you might see in a production environment or on an exam. So this little trivia exercise was beneficial, I think. We learned something about tunnel interfaces and BGP. I will be back here in a little while to do some more. We're going to do next, I believe, I don't have it up here, but it's going to be some more BGP goodness for the rest of the day. Thanks for tuning in, folks. I hope you have a good rest of your Sunday, and I hope to see you here soon in a little while here in the Land Tamer stream.